What is work? In many walks of life, work can be described as a job, household chores, or sometimes homework. But in the language of physics, work can be done when there is force and displacement. And remember, work and displacement are both vector quantities. In chapter 2, we've learned how to add vectors. For today, we will be learning how to multiply vectors. And there are several ways on how we can multiply vectors. One of which is the so-called dot product method. This method is the one that we are going to use when we are dealing about work problem. Dot product of two vectors is called scalar product. The dot product is written and defined as vector A dot vector B is equals to AB cosine theta. Although two vectors are being multiplied, the product is a scalar quantity. Meaning to say that work is a scalar quantity. Therefore, work done is equals to force multiplied by displacement in the direction of the force. In symbols, we have F.D is equals to FD cosine theta. F is the force and D is the displacement, and theta is the angle between them.
Since the unit of force is Newton and the unit of displacement is expressed in meters, therefore Newton times meters is equals to Newton meters, also known as joules. In symbols, we have capital letter J. Erg is another but a smaller unit of work.
So now, let us have some examples and let's find out whether work is present or not. In a free body diagram, when a book was lifted, we applied a force that goes upward. Same goes with its displacement. The direction is upward. So if you can notice, force and displacement is parallel to one another, meaning to say they do not form any angle because they do not intersect. Therefore, angle is equals to 0. With our formula, work is equals to force times displacement cosine theta. Let's say, for example, the value of force here is 10 Newton and the displacement is 60 centimeters. 60 centimeters, we have to convert that into meters. So we have work is equals to 10 Newton multiplied by 0.6 meters cosine 0. Theta is equals to 0, or the angle is equals to 0. And cosine 0 is equals to 1, meaning to say that is 10 newtons multiplied by 0.6 meters multiplied by 1 is equals to 6 Newton meters or 6 joules. In a free body diagram, we can say that once you apply the force on the string that holds the book, it will acquire a displacement just like this. Say for example, the force is 10 newtons and the displacement is 60 centimeters, and again, we have to convert 60 centimeters into meters, so that will give us 0.6 meters. And we can see once again that the force is parallel to displacement, meaning to say that the angle is equals to 0. So from our formula, work is equals to force times displacement cosine theta, we have 10 newtons multiplied by 0.6 meters cosine 0 is equals to 6 Newton meters or 6 joules. Will it be possible for force and displacement to be in different direction? Well, the obvious answer for that is yes. Take a look at these examples where force and displacement are in different directions. Say for example that you pull the string on this direction, you apply the force on this direction, and you have a displacement in another direction just like this. We can see that there is an angle formed between the force and displacement. let's represent that angle as theta. Let's say for example that the value of that angle is 30 degrees. Now, from our equation work is equals to force times displacement cosine theta, we're going to assign another value for force and displacement, 10 newtons and 60 centimeters. So we have 10 newtons multiplied by 0.6 meters cosine 30 degrees, because that is the value of our angle. We will be having an answer 0.87 Newton meters or 0.87 joules. When a book is lifted upwards, we can see that its displacement goes upwards. And there is a certain force that pulls the book downwards, and yes, we call that as the gravity. In this case, we want to know the amount of work done by the gravity on the book. And we can see that displacement and force is in total opposite direction. While displacement goes upward, force or the gravity goes downwards. So we can see that the angle between them is not 0 anymore, but that is equal to 180 degrees. Now, from our formula, force times displacement cosine theta, let's plug in another value here, 10 newtons and 60 centimeters. So, 10 newtons multiplied by 0.6 meters cosine 180 degrees. When we plug in our calculator cosine 180, that will give us the value of negative 1. That means that the answer for here is negative 6 Newton meters or negative 6 joules. Remember that when displacement and force are in total opposite direction, that will give us a negative amount of work. In this situation, we want to know the amount of work given by the friction on the book. So as the book continues to displace towards the right at 60 centimeters, there is a resisting force acting upon it, and we call that force as the friction. And let's say for example that the amount of force given by the friction on the book is 10 newtons. And as we all know, the angle between the displacement and our force is equal to 180 degrees. So 10 newtons multiplied by 0.6 meters cosine 180 is still negative 6 joule. So whenever you have 180 degrees, your value of work will always be negative. Let us say that after displacement, a force of 10 Newton acts upon the book. And if we're going to draw its free body diagram, we can see that force and displacement formed a 90-degree angle between them. So, given that the angle is equal to 90 degree, 10 newtons multiplied by 0.6 meters cosine 90, and cosine 90 is equal to 0. Any number multiplied to 0 will be automatically 0. So the answer for here is 0 joules. It only means that whenever you have 90-degree angle, there is no possible work there. Just like for example, the scenario that we have, once I pressed the book, there is no work happening there.
Before we end, let us have a quick review. Work is equals to force times displacement cosine theta. The SI unit for work is joule. When the angle is equals to 0, the work is positive. When the angle is equals to 90 degrees, no work is done. When the angle is equals to 180 degrees, work is negative. I hope that this video helped you to learn more about the concept of work.
That's all for today. Thank you very much for watching, and do not forget to always activate that mad scientist inside you.